Have you ever wondered how the tranquil, warm waters of the tropics can suddenly turn into a swirling vortex of wind and rain we know as a tropical cyclone? Well, let's unravel this meteorological mystery together. Tropical cyclones, often called hurricanes or typhoons depending on their location, are some of the most powerful and destructive weather systems on Earth. They are born in the tropics, hence their name. But what exactly stirs these giants into existence? It all begins with the sun. The intense heat from the sun warms the ocean's surface, causing water to evaporate into the air. This warm, moist air rises, and as it does, it cools and condenses to form clouds. This process of evaporation, condensation, and cloud formation releases heat into the atmosphere, a phenomenon known as latent heat. This heat is the fuel that powers a tropical cyclone. But heat alone is not enough. For a cyclone to form, there needs to be a pre-existing disturbance in the atmosphere with low pressure at its center. The warm, moist air rises within this disturbance, creating a flow of cooler air rushing in to replace it. This cycle repeats, causing the disturbance to grow and intensify. The Earth's rotation also plays a crucial role. Due to a phenomenon called the Coriolis effect, the wind within the disturbance starts to rotate. In the northern hemisphere, it rotates counterclockwise, and in the southern hemisphere, it rotates clockwise. This rotation, along with the sustained winds of at least 39 miles per hour, officially marks the birth of a tropical cyclone. The cyclone continues to feed on the warm, moist air from the ocean surface, growing in size and strength. It finally dies down when it moves over cooler waters or onto land, where it no longer has the heat energy it needs to sustain itself. So, to recap the fascinating science behind tropical cyclones, they form from a combination of warm ocean waters, a pre-existing atmospheric disturbance, and the spinning motion provided by the Earth's rotation. The heat energy released from the condensation of warm, moist air fuels their growth and intensity, and they dissipate when they can no longer draw on a source of heat energy. The power and unpredictability of tropical cyclones make them a formidable force of nature. Understanding their formation not only satisfies our curiosity, but also aids in predicting their paths and potential impacts, ultimately helping us safeguard lives and property. The next time you hear about a tropical cyclone brewing, you'll know a bit more about the complex, scientific ballet happening over the ocean's surface.